Hi guys, so the question says potential energy of particle varies as the equation is given ux where E naught f is given, ux is equal to E naught f and x is less than equal to 1 and greater than equal to 0. So the de Broglie wavelength is lambda 1 and for xgt the de Broglie wavelength is lambda 2, and we are given that the total energy of the particle is 2 times E naught. So we have to find out lambda 1 upon lambda 2. Okay, so for lambda 1, 0 x and here it is 1. So we know that the potential energy it will be equal to E naught. So the kinetic energy it will be total energy minus the potential energy. So total energy is given 2 times E naught and potential energy was E naught. So kinetic energy will come out as E naught. Now lambda 1 is equal to h upon under root 2 times mass into kinetic energy, that will be h upon under root 2m E naught. Now for lambda 2 we can say x is greater than 1, potential energy here it is 0. So the kinetic energy will be total energy minus potential energy, which will be equal to 2 times E naught minus 0, that will be equal to 2 E naught. So from here we can calculate further, which will be lambda 2 will be equal to h upon under root of 2mk under root, which will be h upon 2m 2 E naught. So we have lambda 1 and we also have lambda 2. We can find out lambda 1 divided by lambda 2, which will be equal to h upon root 2m E naught divided by h upon root 4m E naught. From here we'll get the answer as root 2.
Hello students, our question is, let us assume that the de Broglie wave associated with an electron forms a standing wave between the atoms arranged in one-dimensional array with nodes at each of the atomic sites. It is found that one such standing wave is formed if the distance between the atoms of the array is 3 angstrom. A similar standing wave is again formed if d is increased to 3.5 angstrom, but not for any intermediate value of d. Find the energy of the electron in the electron volt and the least value of d for which the standing wave of the type described above can form. Okay, so we'll calculate the calculate the terms which are asked in the question. Okay, so let us see. As nodes are formed, at each of atomic sites. So therefore we can write so given is 3 angstrom and we can write here n lambda by 2, right? We'll number this equation 1 and another data is given, that is 3.5 angstrom, okay? So we can write here it is n plus 1 lambda by 2, right? So we'll divide equation 2 by 1. So it is 3.5 divided by 3 is equal to n plus 1 upon n. Okay, now if we solve this, If we solve this, then we'll get 3.5 n is equal to 3n plus 3. Okay, so we'll get here n is equal to 6. If you solve this, then we'll get n is equal to 6. Okay, so we'll put in equation 1. We'll put in equation number 1. So it becomes 3 angstrom is equal to 6 into lambda by 2. Right? 6 into lambda by 2. So here 2 3s are 6. So lambda is 1 angstrom. Lambda is 1 angstrom. Okay. Now we get lambda here. So we can write de Broglie wavelength. What is de Broglie wavelength? Lambda is equal to h upon p. Right? So here h, what is p? P is the root of 2m e. Okay, here E is the kinetic energy. Here is kinetic energy. Okay, now from this equation, we'll square this. Lambda square is equal to h square upon twice m e. Okay, so from this we can write energy is equal to lambda square. Sorry, energy is equal to h square upon twice m lambda square. Now we'll calculate the energy. Okay, so energy is equal to h square. What is the value of h? H means 6.63. It is Planck's constant, right? H is Planck's constant. 10 raised to minus 34 square. Now 2 into 9.1 into 10 raised to minus 31. Right? Electron is given, and lambda square. Lambda square means 10 raised to minus 10. 1 angstrom is 10 raised to minus 10 square. Okay. Now we'll write all numbers together. Means this 6.63 square is there. So 6.63 divided by 2 into 9.1. Okay, and we'll write the remaining 10's power. 10 powers are here. Minus 34 minus 34, it is minus 68. Okay, then this is 10 raised to minus 31, and 10 raised to minus 10 square means 10 raised to minus 20. Right? So here plus 31 plus 20 plus 20. Right? Now this all values are in Joule. These all values are in Joule. Now if you want to calculate it in electron volt, then we'll make it 6.63 into 6.63 divided by 2 into 9.1. Okay, and whatever the power is 10 raised to minus 68 plus 31. Right? 10 raised to means minus 68 plus 31 is minus 37, and also plus 20 is minus 17. Okay, we have to divide all these values by charge of electron 1.6 into 10 raised to minus 19. Then this answer becomes in electron volt. Okay, so if we calculate all these values, means 6.63 into 6.63 divided by 2 into 9.1 into 1.6. Okay, this value becomes 1.509, and 10 raised to minus 17 and 10 raised to minus 19 becomes 10 raised to plus 19 in numerator, so it becomes 10 raised to 2. So this answer is 1.59 into 1.509 into 10 raised to 2. So that means it is 150.9 electron volt. Okay, so this is the energy which is asked in question. Now D. So this is the energy. Now D is nothing but lambda by 2. D is nothing but lambda by 2. So it is 1 angstrom divided by 2. That means 0.5 angstrom. These are our answers. Okay, thank you so much.